Okay, so which grows fastest? So we have a quadratic function, we have a linear function, and then we have an exponential function. The question is, which one grows fastest as x continues to get bigger and bigger and bigger? So we're not worried about the part of the graph in here for small values of x. When we're trying to see which one will grow fastest as x continues to increase without bound, really the number one thing that affects it is not this coefficient. I could put 400 here or 4,000 here. And it looks like this one's the fastest, but eventually my exponential, eventually it's going to pass it up and continue to grow faster. Let me zoom out here a little bit more so I can see it. Eventually my exponential crosses the quadratic and grows way faster than my quadratic does. And it doesn't matter what coefficient I put here. I could put 4,000 there. That's just going to make it take a little bit longer. And eventually my exponential is going to cross it. Let me zoom out here and speed this up. And notice my linear is way over here. Growing faster means I'm going up towards positive infinity quicker. So my linear is a lagger. It's lagging way behind my others. Let me see if I can zoom in on this part of the graph and see if, yeah. So my blue graph, my exponential has already crossed it and continues to get steeper and steeper and steeper faster than this one. And I could put a bigger number here, but it's not going to matter. Eventually, this exponential part will continue to pass it as long as my base is bigger than 1. Like I could put 1.1 here, and you'll notice, wait a minute, let me make this 4 again. Okay, and let me zoom back in. Let me just go ahead and make this 0 and 0 and then 0. Yeah, go ahead. That's good. So, I'm actually still zoomed way out. You see my y coordinates are, looks like 500,000. So let me change those to, oh wait, how come? Oh, because I moved it around. So let me make this. Why can't I double click on it? And I'll make this 100 for now, or 100 for now. Okay, so you see, like with my linear, and the y-intercept doesn't matter either. The fact that this is x to the first power means when x starts getting really, really big, like a million and a billion and a gajillion, then a gajillion squared, a gajillion gajillions is going to be way more massive than 100 gajillions. Or whatever constant I can put here, eventually x is going to dwarf it. And even though this grows very slowly, 1.1, if we were to, so notice 1.1 doesn't grow very fast right now. It's like we can't even see it. But if I change my x to go to not 35, maybe 3,500, then what you'll notice is, oh, wow, it does start to climb very fast. Exponential graphs eventually pass up any quadratic. I can change this to x cubed. I can change it to x to the 10th. It doesn't matter what power you choose. Eventually, a exponential graph, exponential function with a base that's greater than 1 will eventually pass it up, which also points out the power, helps to support the power of compounding interest as well. All right, so I hope that helped. You're looking for functions that grow fast. You want exponentials. If I made it less than 1, so a number between 0 and 1, that's actually an exponential decay, and it levels off instead of going up towards infinity. So you want exponential if you want the fastest growth eventually.